All right, so here we're going to review metric conversions, converting among different units using different metric prefixes, because all the time you're going to find that your speed is in meters per second, but your distance is in kilometers, and that's such a pain. So we need to find a way to make sure all the units match, and sometimes it's going to involve converting among these different units using these different metric prefixes. Now, first of all, just a super quick review of SI units, those standardized units that are used the world over for representing different scientific quantities. Okay, so three of the basic ones that you've already been exposed to are, first of all, the basic unit of length is the meter, represented by a little m. The basic unit of time is the second. We're good with seconds. That's represented by an S. And then the basic unit for mass, or how much stuff there is in an object. It's kind of similar to weight. It's not exactly the same. We'll get into that. But the basic unit we use for that is the gram, which is predictably represented by a lowercase g. Now, another unit that we're going to use is the liter, which represents volume, or how much space something takes up. This is not technically a proper SI unit, but it's a nice unit, so we use it anyway. So we've got liters as well in here. Okay. So on top of these units, if we want to be talking about really big distances or really small amounts of time or whatever, we can also add prefixes that indicate that we're talking about this many thousands of meters or this many hundredths of a second or what have you. And those different prefixes are all summarized in this cute little staircase right here. Oh, it's adorable. All right. So our base units, the meters, the grams, the liters, etc., are all right here in the center. Okay, so this center step represents our base units. Okay, and then if we want to be talking about small fractions of a meter, small fractions of a liter, etc., we can add one of these prefixes over to the right, lower on the scale. If we want to be talking about this many hundreds or thousands of these units, we can move to the left, up on the scale. All right. Now, each of these different steps represents multiplying or dividing by 10. So if we go down from the base unit down to deci, so we go from meters to decimeters, we are talking about a unit that is 1/10 the size of the original base unit. Or if we go from decimeters down to centimeters, we're talking about centimeters are 1/10 the size of a decimeter, and so forth. Okay, and then moving up the other way, we're getting that many times bigger. So a decameter is 10 times bigger than a meter. A hectometer is 10 times bigger than a decameter, which also means that a hectometer is 100 times bigger than a meter. Okay. So basically then, as we move throughout the staircase, all we have to do is multiply or divide by 10. And hopefully you've figured out at this point that multiplying or dividing by 10 is equivalent to just moving our decimal over that many spaces. Okay? So basically what we're going to do here is as we move from base units to centis or hectos or whatever, we're going to either add zeros or move decimal points over the same number of spaces that we've moved on this staircase. So just to kind of give you an example, since I'm tripping over my words here. Say we are starting out with 30 meters, okay? We want to end up in centimeters, all right? So we're starting out here at the base unit. We are trying to get to here, centi. Okay. In order to do that, we're going to have to walk down 2 steps. So that means our decimal point is going to have to move 2 places. Now in this case, since we're dealing with smaller units, we're going to need a bigger number of those itty-bitty centimeters in order to make up the same amount of space. So that means we are actually going to be moving our decimal point over to the right. The nice thing about the way that this is set up is that you're moving to the right on the staircase, the decimal point also moves to the right. So we go 1, 2 places over. So we're talking about 3,000 centimeters in this situation. Okay, so see how we moved 2 spaces over? That meant we had to move the decimal point 2 spaces. Since we were moving to the right on the staircase, that decimal point moved over to the right because it's going to take more of these little centimeters to equal one of these bigger meters. All right, let's do another example. All right, so whoop, I don't want to do that. You should still see this. Okay, so say I've got 42 decigrams. And I want to convert that into kilograms. So I'm starting out here in deci, and I want to get up to here, kilo. So I'm going to move 1, 2, 3, 4 spaces. So I'm going to need to move my decimal point 4 spaces over to the left. So that gives me 0.0042 kilograms. All right. Now, hopefully, this is something that you can more or less commit to memory because we're going to be using it a lot. Okay. If you don't want to memorize every single one of them, then let me tell you, kilo is super important to know. Centi is super important to know. And milli is super important to know. If you don't know hecto, deca, and deci, I can handle it. But you need to know that kilograms are 1,000 times bigger than grams, that centiliters are 1/100th the size of liters, and millimeters are 1/1000th the length of meters. Okay? So hopefully this has reminded you a little bit of how you do these different conversions. If you have further questions, well then, you should just come on by and talk to me.